So let's have a look at primary recovery drive mechanisms. The first mechanism to be aware of is what's known as gas cap drive. And here there's a layer of natural gas above a layer of oil. And as the oil is extracted to the surface, the gas expands, and this expansion helps to maintain that natural drive. The second mechanism to be aware of is water drive. And here the pressure in the layer of water below the oil forces the oil up into the wellbore, and this is considered to be the most efficient form of primary recovery drives. Now, another primary recovery mechanism to be aware of is what's known as combination drive, and this is where oil is driven from the reservoir by both an expanding gas cap and rising water level. Another mechanism for primary recovery is known as solution gas drive. Now, as the pressure in the reservoir decreases, gas exhaled from the oil, and this expansion of the solution gas helps to maintain reservoir pressure. So let's have a look at secondary recovery. Now, secondary recovery is used when the pressure inside the well drops to levels that make primary recovery no longer viable. Now, the two most common types of secondary recovery techniques are gas injection and what's known as water flooding. Normally, gas is injected into the gas cap and water is injected into the production zone to sweep the oil out from the reservoir. Now, it's believed that the successive use of primary recovery and secondary recovery in an oil reservoir produces about 15 to 40% of the original oil in place. So let's now have a look at tertiary recovery, or what's often known in the industry as enhanced oil recovery, EOR. Now, EOR involves using sophisticated techniques that alter the original properties of oil. Now, the purpose of EOR is twofold. First is to restore formation pressure to increase the pressure in the reservoir, and second is to improve oil displacement to increase permeability. Now, there are three major categories of EOR, of enhanced oil recovery. First, we have chemical flooding. An example is polymer flooding. Second, we have what's known as miscible displacement, and CO2 injection is a prime example of this. And our third category of EOR is thermal recovery, and steam flooding or in situ combustion are two examples of this. Now, the optimal application of each type depends on reservoir temperature, pressure, depth, permeability, residual oil, water saturations, as well as porosity and the fluid properties such as oil API gravity and how viscous the oil is in the subsurface. So to summarize, we have three types of recovery. Primary recovery, which consists of natural flow due to the natural pressure of the reservoir, or artificial lift, where pumps are used to extract the fluids up towards the surface. Now, we also have secondary recovery, and this consists, for example, of water flooding. And this is done with the principal purpose to maintain pressure in the reservoir. And finally, we have tertiary recovery, often known as enhanced oil recovery. And this is often split into three categories: thermal recovery, gas injection, and chemical, as well as other forms of recovery techniques. Now, the purpose here is not only to restore the formation pressure, but it's also to improve oil displacement in the reservoir. Often, these techniques are very sophisticated, and they often alter the original properties of the oil.